the inclination of a straight line. The angle between a line and the positive x-axis is known as the inclination. In this example, line PQ makes an angle of alpha degrees with the positive x-axis, and this means if I start at the x-axis and I rotate in an anti-clockwise direction up to the line, then this angle is the inclination. Or, looking at line AB, the angle that line AB forms with a positive x-axis is beta. Therefore, beta is the inclination of line AB. If the line has a positive gradient, like PQ does, the inclination will be an acute angle. And if we look at line AB, which has a negative gradient, the inclination will be an obtuse angle. The tan of angle alpha is y over x, and gradient is also defined as the difference in y over the difference in x. So if I calculate the tan of angle alpha, we will get the gradient of line PQ. If I have the gradient of a line, I can, using the tan function, get the inclination. This we can do regardless of whether the line has a positive or a negative gradient, using this formula. Determine the inclination of line with A at -5, 2 and B at 3, -1. It is always advisable to draw a diagram to assist you in the solution of this question. The inclination will be this angle, which we label alpha, so we need to determine the size of angle alpha. We can say that the gradient of line AB is equal to the tan of alpha. The gradient of line AB we can determine because we have two known points on the line. Now we get that tan of alpha equals -3 over 8, and using our calculator we get alpha as -20,6 degrees. -20,6 implies that it is a negative angle, so the angle that we calculated is this angle. To get the adjacent supplementary angle, we can add 180 degrees to the negative angle, and we get 159,4 degrees. Determine the gradient of the line with inclination 75 degrees. We can say that the gradient will be equal to the tan of the inclination, which is 75 degrees. Using your calculator, this answer is then 3,7. So the gradient of the line in question A is 3,7. For question B, the gradient will be equal to the tan of the inclination, which is 110 degrees, so the gradient once again will be -2,7 degrees. Here we see the inclination was an obtuse angle, and therefore the gradient will be negative. Here our inclination was an acute angle, and therefore we will get a positive gradient. Determine the value of angle B if B is the point of intersection of two straight lines, one with a gradient of 2/3 and the other with a gradient of -5 over 2. The best way to attempt this problem is by constructing an x-axis, or at least a line parallel to the x-axis. In other words, a line with a gradient of 0, and this line must pass through B, the point of intersection. Due to the fact that we have the gradient of this line, we will be able to determine the inclination of this line. Let's call it theta, and similarly, because we have the gradient of this line, we will be able to determine its inclination, and let's call that alpha. To find B, we can see that B and the angle indicated here are vertically opposite each other, and therefore they are the same size. This angle will then be the green angle minus the red angle. So angle B will be alpha minus theta, and that is 78,1 degrees.